Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast, back with another article review. Actually, in this case, it's going to be an articles plural review because I'm going to look at two different recent papers that touch on one of my favorite topics, movement variability. In particular, these are going to look at the relationship between the instructions given by a coach and movement variability in a couple different ways. So the first paper I want to look at is a recent one published by Lindsay Waite and colleagues in the journal Motor Behavior, looking at the relationship between different focus of attention instructions and movement variability. And in particular, I want to emphasize this paper because it's focused on female athletes. Injuries in female athletes, I think a lot of people know in sports, are quite a problem and actually occur at a greater rate than in men in many cases. In particular, for example, in basketball and soccer, ACL injuries for knees are 3 times more likely in women. Women tend to have higher forces and stiffer landings, and in when they do, for example, a jump test. So it makes them more susceptible to injury, right? So this is an important problem that needs to be addressed. How can we reduce the likelihood of injury? How can we change these coordination patterns that are putting so much force on their knee and hip and etc. This study falls in nicely with a bunch of topics I've been talking about. I talked about in my book, and I have a page on my website, perceptionaction.com/injury, where I'm collecting resources that are trying to study an ecological approach to reducing injury, right? So the idea that I think one of the really exciting aspects of the ecological approach to skill is it not only helps performance, but there seems to be a growing body of research that suggests that it produces injury. It reduces the chance of injury. And mainly the idea comes from promoting movement variability, right? If we use methods like the CLA and differential learning that encourage you to explore, encourage repetition without repetition, right? We're putting less stressors on your body because you're not trying to do the same movement in the same way every time. And I've reviewed in the past, for example, Orangi and colleagues, great study on soccer showing that training with CLA and differential learning reduced the risk factors for ACL injury, right? So this is kind of a growing body of research, as I said, that I'm particularly excited about. So what they wanted to do then in this study was they wanted to kind of expand on this by looking at the effect of different focus of attention instructions on both the coordination patterns and the trial-to-trial variability. They were using a simple jump landing test, right? So jumping off a box and landing. Their starting point was the idea that external instructions are going to most likely promote more exploration, more self-organization, more variability as compared to internal instructions, which tend to lead to more explicit top-down control where you're kind of bossing your body around, right? So they're starting with the assumption that people have proposed before and I've talked about before, that external focus of attention allows for the body to self-organize, allows for different, more functional variability. Okay. So they're focusing, you get a different movement patterns with internal versus external. They also argued that you're likely to get more variability when you have external focus of attention instructions. So those are kind of the goals of the study. They took 16 females, uninjured females. All of them were participating in sports that involve frequent landing and jumping, like basketball and volleyball. They were doing a jump test, jumping off the box, drop landings. They were after a few practices, they were told to try to somehow adjust their landing to reduce the impact on the ground. They were motion tracked with a Viacom to look at the kinematics of the movement. Okay, so that was the basic study design. The instructions, critically, this was a within subjects design with so that all participants did all of the conditions. So all participants did a baseline with no instruction, an internal focus, intention, and condition, an external focus of attention condition, with the order counterbalanced. So they all did baseline first, then either internal, external, internal, with the order counterbalance, right? So there's always kind of a limitation with this, doing it within subjects design. It means you can have less participants in your study, but you also have the possibility of carryover effects, which always kind of worry me a little bit, especially. So you basically have to forget the instruction you were told before for it to not to have any impact on what you are doing now. So, but anyway, the internal focus, they were told to focus on bending your knees when you land, while for the external focus, they're instructed to focus on landing softly, right? So, again, the typical kind of instructions. And they did these. So they did 7 baseline, 7 internal, 7 external. Okay. So let's look at what they found. What they looked at was basically to look at coordination patterns. They looked at the coupling angles between the different joints. For example, the coupling angle between the hip and the ankle, the hip and the knee and the ankle, right? This is something that we use, we've talked about this when we talk about degrees of freedom research, whether the coupling, the correlation between them, whether it's 0 or not, right? So it's basically a simple way to quantify a correlation. What they found in their study, so these bars are each for the 3 different conditions, they found no differences, right? So people were doing the same thing in both conditions, which is, not typical what you find but in focus of attention research, but that's what they found in the study. What was significantly different was the trial to trial variability, okay, in these angles, in this coupling angles. So they used a coefficient of variation, which is a way of quantifying variability, kind of like a standard deviation, but in a different way. And what they found was that in the external focus of attention condition, as they predicted, you're getting higher variability from trial to trial, particularly in the hip ankle and the knee ankle, right? So, building on kind of James' variability injury hypothesis, this is a good thing, right? We're achieving the same landing with using different movement patterns, right? Which presumably would help to reduce injury, right? There's less stress on the same joints, tendons, muscles, etc. So what they concluded was that greater child-to-child variability for external focus of attention condition likely reflects an attempt to exploit a wider array of coordination patterns in order to achieve the desired outcome of landing with lower impact forces and less stiffness. Right. So kind of another study. This seems to be, along with doing the CLA and differential learning, external focus of attention instruction seem to be another way to kind of promote this beneficial variability that reduces the chance of injury. A couple things, critiques of the study, along with the within subject design. There's always more things you could do. I would have liked to seen them actually measure the forces the person doing, so to show that they were reducing the impacts. And then in that same sense, showing that this additional variability in landing was actually functional, right? Was it actually helping to reduce the forces and make them less chance of injury, right? Right, as we've talked about in the past, like in things like uncontrolled manifold analysis, not all variability is good, right? You need to kind of evaluate whether it's function, it's keeping you within your goal, but using kind of repetition without repetition. But anyway, I think this is a really interesting study, and it adds to that growing body of work showing the benefits of very self-organization approaches for reducing injury. The second study I want to talk about, look at, is a really interesting one by Ricky Lindsay and colleagues, published in Research Quarterly for Exercise and Sport this year. Their title of the paper is Prescription of a Specific Form Necessary for Optimal Skill Development on Nonlinear Pedagogy Approach, right? And this with people you might recognize like G.A. Chow, who I've interviewed on the podcast before. So this is a kind of a really interesting paper. This is a nice paper because it's you're going to see it's adding to the body of work, directly comparing a traditional kind of linear approach to skill development versus a non-linear ecological approach. Okay. So the idea is that, what we're going to do is, the idea in nonlinear and ecological approach, of course, is one of the key points is the functionality of movement variability, right? Allowing an athlete to explore different movement patterns, allow them to organize, allows them to take advantage of different opportunities, for example, in preventing injury, like in the first study. Rather than doing it one ideal way, you're allowing them to take it individualize, do stuff that works for them. You can, there's an interaction between the learner's constraints and the constraints of the task you create in the landscape, right? That's the basic idea, one of the basic ideas, right? So learning evolves, an ecological approach, exploring, compiling, and stabilizing behaviors. Okay. Um, this study, the task they're going to use is weightlifting, right? They're going to use basically a clean and jerk movement in weightlifting. And what they're building on is some interesting work showing that, you know, I mean, consistent with all the other sports, right? Elite people don't do the same ideal technique, right? And particularly, they looked at in this study, this ACUS in 2012, they looked at the trajectory of the barbell, like so how it's going to move as it goes from the ground up to you holding it over your head. What they found was that people use very distinct barbell trajectories, right? Even though they're receiving the same goal of lifting this very, very heavy weight, right? So these findings suggest that expertise is characterized by achieving specific goals through stable yet highly individualized movement solutions rather than acquiring a specific ideal coordination pattern, right? So this is all stuff we've talked about before, the basic ideas of the ecological approach, okay? So what they wanted to do in this study, right? They wanted to look at, if we'd use an ecological approach, in particular, they're going to use a constraints-led approach most primarily. We're going to look at how coordination patterns develop. What we've seen in previous research, for example, in some of the small-sided games research in soccer that I talked about in my book and I've reviewed on the podcast, is when you use the ecological methods like the CLA and differential learning, you still see the basic fundamentals develop, right? You get the basic movement patterns. People learn the correct, the optimal side of their foot to pass a ball, a baseball swing, and so on. Okay. Um, those what they point out in this paper is that most of those are open skills, like playing soccer, baseball, where there's a room for more variability. What they wanted to do in this study was extend this kind of comparative research to more closed skills, where there's a relatively less variability required. There's less decision making. There's less chaos and cognitive demands. For example, in the task of lifting a weight. So the learners are pattern, typically in these kind of movements, right? We're learning to create a typical, a particular ideal movement pattern with low variability, right? So they wanted to see what happens when you do more of a promoting exploration and self-organization in this type of weightlifting environment. Okay. So what they were looking at was weightlifting movement, the snatch and clean. Okay. Obviously, this is a very dynamic skill that involves coordination of multiple parts of your body, right? You're basically using all of your body. Okay. Um, the way that they quantified and they looked at movement variability in the study, as I said before, was looking at the barbell trajectory, right? And what if you can see that in the paper, they have figures showing basically there's three different types of trajectories people use, right? And in particular, what we're talking about is where does the bar go relative to your body, right? If you can think about someone doing this, right? So imagine someone taking a barbell loaded with heavy weights and lifting it up to their waist and over their head, right? Um, what you'll see, and if you go to the gym, you can see this. You can see that there's some people that keep the barbell very close to your body the whole time, right? And this has been labeled the ideal, right? Because you're not wasting force, you're keeping the weight all under your center of mass. And then there's people that loop the weight more. That is, they kind of throw the weight out in front of them, away from their body, to generate the force to get it up high, right? And these are illustrated in the figures. If you look at the bar position over time, where sometimes it's staying very close to the person's midline, sometimes it's going out, sometimes it's going back, right? So they're doing there's these different types. As I said, the ideal seems to be keeping it close to your body. Okay. So what they wanted to do in this study was to investigate the effect of nonlinear practice in relation to linear practice for beginners learning to do the power clean. Okay. They hypothesized that the linear people would develop a higher prevalence of the type 1 barbell technique, which is keeping the weight close to your midline the whole time. As because they're being going to be prescribed that solution. They're going to be told this is how you do it, as compared to the more self-organization ecological group. Number two, their second hypothesis was that modifying constraints would help shape the perception motor workspace to optimize exploratory behavior and guide nonlinear pedagogy learners towards task-relevant areas. The basic idea, using the constraints-led approach, people should develop a weightlifting coordination pattern that is effective and is maybe slightly different than the other group because it's going to be optimized for them. Okay. They would expect both groups to improve performance. that in terms of how far forward and backward the weight is going, the barbell, right? We don't want it to go really far forward and backwards, right? We want it to stay at your midline. That's going to be their main way of quantifying performance. So in this sense, this study is interesting in the way that it's framed, right? In the way that it's framed, it's not so much trying to show that nonlinear pedagogy is better, right? It's developing better things. There is that element, but it's mostly trying to show that the same components of this ideal type A1 technique of keeping the barbell close to the midline will emerge in a nonlinear approach if you just allow them, right? They're basically arguing you don't have to prescribe and exactly tell the person how to do these movements to get that pattern. That's really kind of what they're testing, right? So they're really almost testing the null hypothesis that there'll be no difference in some sense, right? They are expecting individual differences still because people are exploring more. I'll get to that. So in the study, the methods, they use 16 novice weightlifters. What they found, they found most of the people they work with had some typical flaws that people start with, like jumping forward your feet, um, and, losing your balance, swinging the bar really far forward, improper hip extension, so on, right? So they had these a lot of them are again characterized by the barbell going way away from your midline, okay? Participants were randomly assigned to either the nonlinear pedagogy or linear pedagogy group. Now, as I said, nonlinear, I would call the nonlinear group constraints-led approach. They did 4 weeks of training, okay, in this. The nonlinear pedagogy group, they were designed to obviously to explore, be more variable, promote different solutions. That what was done in the practice, variability was added by modifying the task constraints to encourage the learner to establish this kind of ideal pattern, but allow them to be individual. Example manipulations included chalk on the barbell, poles in front of the participant, right? So chalk on the barbell you could use is a constraint that a lot of people use in weightlifting training because you can tell the person lift the weight so that you get a chalk mark on your shirt, right? That helps you keep the barbell close to you. Poles in front is going to stop you from throwing the bar out in front of you, right? So that's, to me, this is classic constraints-led approach. We're adding a constraint that is taking away a movement solution that you don't want and pushing the person towards a different one, right? So the chalk on your shirt, right? You'll never be able to achieve that if you're throwing the weight way in front of you, right? So I've added a new task constraint that makes you stop doing this and try something else, but I'm not telling you how to do this new solution. So to me, this is a perfect example of the constraint-led approach. They did give some instruction because they wanted to make sure that people had a safe technique to step. Um, they use analogies like keep your back firm like a rod or think about sitting on a chair to get kind of the basic form. So there was some analogy instruction with this in the nonlinear group. The linear pedagogy group involved explicit instructions, repetitive practice, and the coach providing feedback to correct errors towards ideal technique. There are specific instructions about the different phases of the power clean in terms of what your body should be doing. They're in the paper if you want to go look at them. They're built off of manuals on how to learn. Pulling the barbell towards the body. So they're kind of telling you what to do. They're giving you the solution, right? Instead of using these constraints to allow you to explore. So it's typical prescriptive instruction that's very commonly used in weightlifting. Some people could say this is a straw man, but it's what people do in the actual sport. So I disagree with that characterization. Okay, so those are the two different categories. One, encouraging exploration through constraints that push you towards away from a non-ideal solution, and one trying to give you the ideal solution. Okay. The main measures, what they measure, they measured the distance of the barbell traveled away from the midline, forward and backwards, as a measure of performance. Okay, right? We want you to keep it near the midline. Um, they also categorize the trajectory to identify different coordination patterns. They categorize each lift. They categorize into one of 4 categories. Okay, they had 4 different types, which you can look at in the paper. Basically, they're determined by whether you throw the weight forward, keep it on your midline, right? So they're creating these distinct categories of lifting. Okay, so for example, type 2 is initial forward movement and then away, but does not cross So it does not cross the midline, right? So keeping the weight in front of you the whole time, basically, is one of the types of trajectories. So what they're going to do is they're going to categorize each lift into these four, and then they can do a cluster analysis, very similar to the Lee et al. Tennis study I talked about lots of times on the podcast, where they looked at training tennis strokes, and they found that people that were given a constraint set approach use a greater they had more clusters. So basically, you can look at how many of these do you actually use when doing in the different groups. Okay, so they're going to do a cluster analysis to exhibit movement patterns by each learner. They're going to look at, so by each learner, how many different clusters. They're going to look at how many, so that kind of gets at how many different things are you exploring, right? So if we're really exploring different solutions, we might expect you would do a type 1, type 2, try them all, right? What they also did interestingly is they looked at over time, across time, what kind of clusters were you using, right? If you were doing the same type, like several trials in a row, they were categorizing that as exploitation, right? The idea, we talked about this in Newell's work, the idea of exploration versus exploitation. You explore to find a general coordination pattern that works, then you stop there to parameterize it and optimize it, right? And so the idea here is you explore these different types of movements of weightlifting, you find one that works for you, then you keep doing it over and over to kind of perfect it, right? So what they can do is they establish this ratio of the number of exploration behaviors where you're going from different types, trying very different coordination, versus exploitation where you're doing the same type on consecutive trials, right? So a very interesting analysis in this paper. So I'd encourage you to look at the actual paper that goes into it in more detail. What did they find? What they found the main finding in terms of results was that over time in training, the forward displacement of the barbell, which was large at the start for pretty much everyone, decreased. So you're keeping your body more closer to the midline, um, after training. So that kind of forward displacement of the barbell decreased with training, which is what you want. This happened for both training groups, right? So even though, and then there's no significant difference. So one way to look at this paper is that you don't need to prescribe this kind of keeping it on your midline for it. It will emerge on its own with appropriate constraints. There were some differences in terms of the actual coordination pattern. For example, type 2 trajectory only was seen in the nonlinear pedagogy group. But overall, there was not a significant difference in the number of different movement patterns explored, number of different movement patterns exploited between the different groups, right? So this chart shows on average, the nonlinear group explored 7 different clusters during training, okay? And they exploited 3 of them. The linear group explored 7 as well. Okay, so there was really, unlike previous research doing these kind of direct comparisons, there wasn't really evidence that the nonlinear ecological approach promoted more exploration, right? Both groups seem to explore the same number of coordination patterns. There was no significant group difference in the time series either, right? So both groups showed a tendency to stabilize preferred movement patterns, right? So if you look at the clusters over time, you see they're exploring some, but then you have these long series of trials where they're doing the same one, trying to explore it. That was similar for both the groups as well. So what to make of this, right? So one of the key points is, right, as I mentioned before, is that the linear pedagogy group, who were told exactly how the solution, did not show more prevalence of the type 1 technique that we want, where you keep the barbell close to your midline. So this idea, this kind of, for me, builds on this body of research, as I said, in soccer, that there are going to be, if a movement pattern is needed, if there's an invariant, I call them invariant of movement that is required for the sport, the skill, it will emerge on its own with appropriate constraints. You don't have to give it to the performer beforehand, right? To me, this builds on this, right? The idea that you have to give all the fundamentals before you can play the sport, I think this research is adding to the body of work, showing that's not necessarily true, right? With appropriate constraints, you can get right into doing the skill coupled And the fundamentals, the required, the invariant properties that need to be there will emerge. Okay. Why wasn't there more variability in the nonlinear pedagogy group? Why didn't they show additional benefits? Right, you might expect them. There was no differences here. The authors argue, and I agree with them. I think, right, if we think about constraints, right, remember we have our triangle, we have task, environment, individual, right. The key point is these interact with each other, right. The coaches in this study, the coaches in the nonlinear pedagogy group are obviously manipulating task constraints with the poles, the chalk, etc. But in with something like weightlifting, the individual constraints, right, required to keep you safe and being injured, are likely to be very, very strong and kind of overwhelm some of the task constraints, right? In other words, there's going to be unlike other things in soccer that are more open and involve incision making and things like that, with weightlifting, there's only so much exploration you can do because you're very, very constrained at the individual level, right? With what is a safe movement and what your body allows you to do. So adding all these task constraints may not promote as much exploration as you get with other more open skills, right? So that's what the authors argue, and I tend to agree. I think that's probably why we got this kind of effect in this study. But anyways, I think this is very interesting. Here's the author's conclusion. These findings suggest that both prescriptive, linear, and exploratory learning strategies, nonlinear pedagogy, allow for the expression of a range of movement patterns and can be implemented to improve performance outcomes. This has important implications for the attitude of the coach or teacher. For example, for prescriptive learning strategies, the coach is expecting a specific movement, and the inability of the learner to exhibit the prescribed technique may be a source of frustration as the coach aims to produce a specific movement pattern. Okay. Um, so I think this is a good point here. I think, I think this fits with kind of Franz Bosch's, the body has very little interest in what the coach has to say. So even if you're going to be very prescriptive in your coaching and tell person exactly what to do, in cases like this, and especially where there's large individual constraints on the task, the person is going to be not likely to listen to you, right? And do kind of explore different ways, even despite what you're saying to them. So even in prescriptive instruction, I think you can get some of these kind of exploration, particularly as a coach, if you kind of let it go after the initial detailed instruction and you kind of let them do on their own, which, we see examples of in sports. The other thing I think this study shows for me is that, adding task constraints manipulations are not necessarily a precondition for more exploration, right? They can be, right? But it depends on the interaction between the task, which I think this study nicely shows. Um, and another thing they say, although linear pedagogy instructions aimed at direct learners to a specific technique, it's possible that these instructions do not completely nail the field of affordances available, right? Meaning that movement corrections still allow for some exploration, right? So it's possible to give very detailed instructions, but and the person's still exploring different movement patterns, okay? Um, they so even they're showing, at least in this condition, their prescriptive linear instructions didn't completely constrain the learner, right? Allowed for exploration. So I think these are kind of important points. Um, I think I think the bottom line, the effect of the ecological approach may be different for more closed form sports as compared to more open sports, right? And this is something we've talked about all along. There's going to be the amount of variability needed and involved in a sport is going to be relative to the skill, right? And I don't think it gets rid of the central premise of the ecological approach. There's just going to be different effects and different results. And as I mentioned at the start, I'm adding this I have on my website, perceptionaction.com/comparative. If you want to look at it, I have a growing list of studies that make direct comparisons between an ecological approach, whether it's constraints-led approach or differential learning, and some type of prescriptive instruction. And we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 now. Most of them showing clear benefits of the ecological approach. But in this case, though, we're seeing no significant differences. So I will keep adding to this and reviewing these studies as they come out. I think they're really important and really interesting. So that's it for today's episode. Thanks for joining me. And cheers for now, and keep them coupled.